Hello, Ron Gerber here from AngelBee. I'm so glad that Ryan Berry, a top cloud solution architect with Microsoft in the greater Detroit area, is going to be our featured speaker. There's so much interest in how technology can improve manufacturing operations. It's not just sensors on remote pipelines. It's how do you tie together all this data for greater efficiency. These are very challenging times with the coronavirus, and we're seeing a resurgence in using technology in all aspects of our life, and this in many ways could jumpstart the deployment of cloud technology, IoT or industrial IoT in various operations, because it could help organizations respond quicker, help manage supply chains better. We've all heard all the stories about not being able to get the right equipment to build mask or produce mask or produce hand sanitizers. And in some way, we hope that this temporary crisis might jumpstart the use of the technology that can make all of us rest a little easier. So with that brief introduction, I'm going to turn over to our subject matter expert, Ryan, who's going to offer these fantastic insights. All yours, Ryan.
Yeah, thank you, Ron. You definitely highlight some key and salient points, and that technology, I think, plays an ever more increasing role in the daily operations of a lot of manufacturers. And it's interesting because if you do some exploration on what the cloud can do for customers when it comes to, or even individuals or hobbyists when it comes to IoT, you'll immediately find all kinds of examples and demos involving, Raspberry Pis doing temperature collection and that sort of thing. And it's really sometimes challenging to extract that or extend it into a real world scenario and how it can provide business value to a customer who's actually manufacturing something, or as indicated in the pictures, operating oil wells or discrete manufacturing, or operating power plants in a variety of different fashions. You think about it, that all of these operations emit massive amounts of data, and with data and the power of the cloud, you can do some interesting inferences and analysis of that information to streamline your operation, make you be able to respond quicker to market conditions, or be able to build higher quality parts, be able to detect a situation that might actually cause your parts or products to have impaired quality earlier rather than later. Give an example of that, where I'm working with a manufacturer that makes bottles, and there's obviously immense amounts of heat involved in those types of operations. And if you picture tunnels where these bottles are being cooled, the ability to inspect with electronic equipment, at close to where these furnaces reside is challenging. And with the advent of a lot of inexpensive microcontrollers and industrially hardened cameras and that sort of thing, we can actually move the data collection closer to where things are being produced and detect a failure condition very close to where the parts are being produced, as opposed to an hour later where where the first bottle has a defect comes out of the cooling oven rather, or cooling tunnel, and then you've got potentially thousands or tens of thousands of bottles behind it that all have defects as well. So if you catch that earlier, you end up reducing waste, and improving your quality, and that's just one of many examples of how IoT can come into play to help customers. The challenge with that is that in the manufacturing world, IoT has tentacles that extend into all sorts of different facets of our daily lives, whether it be smart thermostats in your wall in your house, building automation and control, or power production. But the focus here today that I was gonna have some discussion and dialogue around is in a manufacturing space, and it tends to be very broad and complex. So lots of different manufacturers of industrial controllers, robotic systems. Typically, let's picture an automotive plant. They go to a supplier or vendor to build a manufacturing cell that actually is responsible for building some very minute aspect of the overall componentry involved in a vehicle. And that vendor has guidelines they have to adhere to that some of the big three might publish in terms of how they wire the control panels and how they interface with plant floor equipment. But really what tends to happen is that vendor has relationships with their own partners that provide equipment that they end up using in that cell. So an example of that, going back to my original talking point, that you have a vendor that actually creates a manufacturing cell might pick, a Siemens controller, Allen Bradley controller, and maybe, another vendor that decides to go with a different type of controller to operate, whatever sort of application that they are hired to accomplish. So you end up with this disparity of different devices that need to communicate with one another. They're all emitting massive amounts of data, and being able to make informed decisions and interface with those equipment, with a piece of equipment, tends to be a challenge when you think about all these different protocols and vendors and manufacturers and that sort of thing. So it definitely becomes a fairly sophisticated space. So why does that matter? I have some statistics here that underscores why this is an important thing for companies to focus on. We talked about a couple of these and reducing costs, kind of jumping around a little bit on the slide, giving an example of the bottle manufacturer. And there's industry analysts that are predicting close to $200 billion in cost reduction by this year alone, with applying some of these concepts of intelligent manufacturing and machine learning and artificial intelligence to be able to look at this massive stream of data and be able to make informed decisions, or help customers make informed decisions. You can reduce energy output. And using the example of a bottle manufacturer, if you have massive amounts of energy that goes into running ovens to be able to to melt the glass down and and put them into molds. And if you can detect a failure mode very early on in that operation, you don't have energy that's wasted in addition to the raw material. And then you can increase your overall efficiency of equipment. If you think about a really important thing in the manufacturing world is overall equipment efficiency, effectiveness of OEE. And if you think about making a big capital investment in a manufacturing cell that's got maybe comprised of robots and a bunch of different various pieces of equipment, you want that to run as efficient and productively as possible. So if through the advent of data capturing, you can determine that when this pressure starts going high and this temperature, bearing temperature on this motor starts climbing, that's indicative of a situation that's going to cause a cascade failure of a bunch of components in your manufacturing cell. And if you can detect that earlier, that increases the efficiency of your equipment, maybe being able to change out some parts during a break or some planned downtime, as opposed to having the thing blow up and maybe cause a much bigger disruption. So you can see just through those simple examples that interfacing with these plant floor pieces of equipment and gathering that data and telemetry really makes for a powerful story when it comes to being able to draw down costs. It's much more than just using a Raspberry Pi and a desk to capture temperature data and plot it on a chart. So, and this is where it kind of goes into some of the challenges when I talked earlier about things like vendor lock-in, devices that don't operate with one another. And then when you think about, a typical manufacturing plant where you have, maybe hundreds of manufacturing cells, many assembly lines or many production lines, that involves the, emitting massive amounts of data. And additionally, when organizations and manufacturers purchase these pieces of equipment, it's a big capital outlay. So they buy all of the PCs and control equipment as kind of an appliance, along with all of the hardware that runs that manufacturing cell. So with that, they plan on it lasting maybe 10 years, 15, 20 years. They expect to get that kind of life out of that huge upfront investment. So because of that, it makes it challenging for them to move forward and maybe evolve and adopt some of the newer capabilities and technologies that are available, maybe with newer, industrial control systems, programmable control systems, um, or robotic controllers and that sort of thing. An organization or manufacturer is not just going to change it just because it's got some cool new features. There's an element of ROI that comes into play as well. So when you think about that, this is kind of showing, time to value, that there's a lot of different paths you can take to just get started, kind of on the left-hand side of just capturing data from programmable logic controllers. Maybe you don't really know what meaningful data to capture, but using some capabilities I'll talk about in a moment, you can push this data into very inexpensive storage repositories in the cloud and start making sense of it. And some examples of that, working with another manufacturer, creates a lot of building products, and they wanted to improve their product quality and reduce waste. I mean, it's kind of a common theme in a lot of customers I talk with, but they weren't really sure how to do that. They had lots and lots of data being produced, and they didn't really know what data elements were related to others that actually would yield, some sort of, bad product or a failure mode on pieces of equipment. So starting with just capturing a lot of that data allows us to start overlaying, some of the other capabilities of cloud, such as, machine learning, some of the analytics capabilities to really, start drilling down. And then, when you take a step forward, beyond that into, some of these other capabilities that are available, such as, a plant with all these disparate pieces of equipment and devices. How do you integrate with those devices and be able to connect to them? So you have different manufacturers, different vendors involved in building robotic and programmable logic controller equipment on the plant floor. There's some some abilities with cloud that you can use and leverage to be able to get data from those environments, and without having to make massive overhauls or changes in equipment you've already deployed. And then you're kind of walking up the chain, using my building manufacturing product company. Once you have data captured, you're interfacing with different pieces of equipment, you can start surfacing that for, maintenance operations. Maybe having dashboards to be able to show maintenance personnel what they need to address more immediately, calling attention to that. And then you're thinking about some of things that I just mentioned on the left side. I'll just go ahead and jump all the way over to the right side, where you can actually extend all of the stuff that we're talking about into a closed loop manner. So in a very specific example of that, we have these interfaces to machines running on the plant floor. We have established some some protocols around correlations of data that's arriving from these pieces of equipment. In my example about temperature and pressure from causing two early warning indicators that might yield something about to happen on a manufacturing cell. Wouldn't it be great if you could actually have the equipment then respond automatically? Maybe automatically dialing down the pressure or slowing down the feed rate on a motor to be able to, that has a bearing that's about to fail, to be able to, allow you to continue hobbling along, but not, causing this massive disruption where you might, spiral out of control and have a bunch of things blow up in the plant floor. So that's kind of where the closed loop part of it comes into play, where you can extend capabilities from the cloud that's actually analyzing this data in real time, sending messages down to edge devices running on the plant floor that can then respond and react and send in process control or change process control parameters to be able to stop a failure from happening. So you think that's a really powerful story. Obviously, it takes some some time to actually get to that point after amassing data and creating the models that can look at that data and make informed decisions. But that's where real dollars and benefit to customers come into play. All right, so that's really all of what we've talked about today is so far is just kind of all encompassing of what I refer to as just industrial IoT. And Azure has a lot of capabilities. You know, being a Microsoft employee would would be remiss in if I didn't mention that. I work with Azure daily. I work with a lot of customers being able to make use of Azure for being able to solve some of these problems. And I thought it'd be interesting to kind of explore one of the really powerful tools that we have in our arsenal to be able to do a lot of what I just described. And I'm going to flip over to another slide deck here. So, you know, I talked about a lot, you know, taking all this data from pieces of equipment running on a plant floor, pushing it up into some data repository. And I say some data repository because we have a plethora of them in the cloud, and the direction and pathway you choose is really dictated by a number of different factors. So let's just say that you take this data and put it in some landing zone in the cloud, you know, one that's appropriate for whatever, you know, whatever the intended use of that information. You know, that's all well and good, but then what happens if now you have your plant tightly coupled to services running in the cloud? You know, if you have a contractor out, you know, digging in your parking lot to putting in, you know, parking lot lamps, and they strike your internet connection to the plant. You don't want to idle that entire facility because, you know, your primary connection to the internet is down. Nor do you want to have any sort of disruptions in the plant if there's, you know, some sort of momentary hiccup or interruption in the cloud, you know, some service interruption. And that's where having a powerful story of extending some of those capabilities and running it on the edge becomes really impactful, to be able to take some of the capabilities of the cloud, move them to compute on the you know, directly in the plant that actually is tightly coupled to pieces of equipment that you know, I was talking about earlier, being able to address some of the protocol and impedance mismatches and different, you know, vendors that you might be dealing with in the plant floor, being able to directly and easily reach out and grab that data, maybe do some analysis and processing at the edge, and then, you know, sending some of the decisions and maybe, you know, summarize data up to the cloud. That becomes a much more compelling story to a manufacturer when you've reduced that dependency and connectivity to the cloud. So I've already just kind of talked about a lot of this. So basically, you know, our edge capabilities involves I'm going to go ahead and flip to the next slide here. So we have some capabilities in Azure that allow you to run serverless code, what we call Azure Functions, as well as being able to run time series insights. You know, obviously we have SQL Azure, you know, for data is one of the many data storage locations that you can actually land data. So we actually support taking a lot of those services from the cloud and actually running them locally. And this edge device can be as simple as a Raspberry Pi, because it's really just a bit of software that can run on a Linux environment or a Windows environment. So basically you can take any type of box or compute device and be able to, you know, you know, run some of those cloud functions locally, in addition to being able to deploy code that you've authored yourself directly on those devices from the cloud, so you can centrally manage and view those edge devices, and I'll show you that in a moment. In addition to being able to make use of things like OPC connectivity to, you know, PLCs, programmable logic controllers that may be running your manufacturing environment. So you can run all of that locally, be able to make decisions, and actually you know, run some of the machine learning models and AI insights and so forth locally on the edge, in sending some of that telemetry up to the cloud for being able to do more historical analysis, or retraining machine learning models and that sort of thing. So you know, obviously the benefit of all of this is that that connectivity or link to the cloud is not required to be able to make any of this stuff work. You can actually, you know, configure the devices, provision the devices, define the behavior of those edge devices, and once they're deployed, you can actually have them run autonomously, really only relegated by, and the amount of time they can run disconnected is really only relegated by the amount of storage that they have on available. So, if it's a more capable industrial PC that's maybe installed in an electrical enclosure on the plant floor that has a lot of local storage, it could run maybe for a week or more without having any sort of connectivity to the cloud. So I'm going to go to one more slide here, and then I'll kind of show a little bit about how it works. So we have this service in Azure called IoT Hub, and that's actually a bus, a scalable bus, a communication bus that you can send messages to. And devices can actually send messages directly to IoT Hub. Devices can actually send messages to IoT Hub through an edge. So you can actually have, picture having an edge sitting in a plant and actually have devices strung to it, and having the edge in turn, feeding that data up to the hub. Or they can receive messages directly from the edge with respect to logic that you have deployed on the edge. And by logic, I mean custom code that you've authored, maybe some Python, .NET code, any type of application that can be packaged into a Docker container can be deployed onto that edge. The edge obviously also has local storage on it, as well as some runtime components that are deployed that actually define it to be an edge, which is the components that we make available to customers to use to configure a PC running Windows or Linux to become an edge. So that edge is provisioned in the cloud, and within the cloud, you actually identify what you want to actually deploy onto that edge. And by deploy, I mean what do you want, how do you want the edge to behave? How do you want it to be configured? So like I said, it'll make more sense when I show you. So you define that representation of that device in what we call a device twin. So this is a digital representation of the edge device that actually has details of its last reported health, what versions it has running of code that's deployed to it, maybe parameters that you might want to set, for process control parameters and so forth. You can actually see the last reported state of those parameters in the hub. And I say last reported state because remember I said that this connection or link doesn't have to exist for any of this to work. So if this link is down, you'll see the when it last talked to the hub, and whatever its process control variables are. And then finally, you can define, what do you want to have deployed down to them, or down to the edge. So this could be a combination of any and all of this stuff up here on the right-hand side. So I'm not going to go into great detail on stream analytics and machine learning and AI services, but basically we have components that can run in the cloud that can look at this hot stream of data that's arriving from your plant floor and be able to help you make informed decisions about it. You can take those components once you've actually trained them in the cloud and move them down to the edge. So now you're able to run in that disconnected state and be able to make decisions and communicate with with some of your manufacturing equipment that you have in the plant floor. Also, because these modules that are running on the edge are really Docker containers. They contain code that actually is altering the behavior of the edge. You can actually control how you want data to flow through these modules. So as an example, I could say I want, maybe this is my OPC UA module. So this is actually interfacing with my controllers on the plant floor. So once this captures data, maybe I want to send it to another module to look to see if maybe it's to see if I need to generate an alert to a maintenance technician that maybe some conditions are being met that I want to be able to immediately respond to without having to send that data up to the cloud. And then maybe I can send it to another module that actually has some machine learning models that actually is applying to that stream of data as it flows in, and maybe a final module that actually takes that data and stores it locally in the event that this connection is down. And then if that connection actually is restored, we'll actually walk through all the data stored locally and push it up to the cloud. So you can kind of think of it as a all-encompassing package that can be run and installed fairly inexpensively next to the pieces of equipment where the data is actually produced. So there's a lot of vendors and manufacturers that make these edge devices, which are really just industrial PCs. You can take any industrial PC from Advantech, Moxa, all these different vendors that make these industrial PCs, and they range anywhere from like $300-400 on up to many thousands of dollars, depending on what sort of capabilities that, and how much memory, what type of processing power and storage. And finally, within the IoT Hub, you can define what sort of you can actually see the like the device twin. You can actually see a twin of the actual modules that are running on the container or in the edge. So where this becomes really useful is maybe you have. I talked earlier about maybe this module being something that's looking at data real time and sending an alert to a maintenance technician, maybe when the pressure of of a particular valve exceeds a certain working threshold. So you can actually control maybe the parameters of that pressure centrally in the cloud and have it get pushed back down to the module. So the benefit there is if you picture a typical manufacturer that has plants all over the globe and maybe wants to make adjustments to all of their plants or maybe selected plants and then what deems a high pressure from a particular actuator or piece of equipment, you can do that centrally and have it rolled out to every piece of equipment or every module that you have attached to your pieces of equipment. Then I talked about some of the downstream devices where you can have things like programmable logic controllers or sensors that actually have Bluetooth Low Energy or other sorts of direct connectivity capabilities. So they can connect directly up to the edge and be managed again through the edge from the cloud. So it's a pretty powerful story, and you think about being able to move some of that processing down locally to where the devices are. So the way this works, this is actually what I'm actually looking at right now is I'm in the Azure Portal, and I'm looking at a IoT Hub. So this is actually showing messages that are arriving from sensors and some of my edge devices. You see I don't really have a whole lot of activity at the moment, but I can also see what we call device twin operations. So this is where you make a change in the cloud and it gets reported back down to the devices running in a plant. Also in here, I can actually manage intelligent devices. There's a plethora of manufacturers that have the ability to directly connect over some industry standard protocols such as MQTT or AMPQ, which are some industrial protocols that can talk directly to the cloud. But what I wanted to focus on was the edge part of it. And I get a number of Raspberry Pis sitting here on my desk, and so I can actually see the individual devices that I have provisioned. But this is where it gets really interesting. When I talked about those modules, I'm going to go ahead and drill into one. So these are the modules, and these are Docker containers that are actually running on my Raspberry Pi at the moment. And the way this works, if I go to Set Modules, I actually have a number of modules running locally on my device that actually has Grafana, which is kind of a dashboard, as well as InfluxDB, which is a time series insights database. So I actually have that running on my edge device. And these modules, if I actually look at this, it's actually running inside of a container registry. So this is a Docker container. So basically I create a definition in the cloud to say, okay, whenever this edge device connects, I want the edge device to download this Docker image that contains the logic I want to run locally. And you can provide environment variables that are specific to that container. So if without talking very deeply about how containers work, it's a way to kind of isolate runtimes on a machine. So you can run Docker on your workstation locally, or you can run Kubernetes is another cloud-hosted capability that allows you to run containers, and it's a way to create kind of isolated units of work similar to that of a virtual machine, but in a much lighter weight fashion. So you don't have all the overhead of running multiple operating systems on one of these edge devices. It's a this particular container, I think, is like 180 megabytes. So very small image that contains all the stuff needed to run Grafana. And within that container, I can actually provide environment variables just like I could if I were running this locally on my machine. But I can also provide details to this container of how I want it to leverage the devices, the edge devices network interfaces. So I can actually have it tap into the network interface on the edge. In this case, I'm actually telling it that when you're running, I want you to take port 3000 within the container and expose it on the network interface on the edge, also on port 3000. I can provide it some variables of how to access Grafana. This is my default username and password. I can tell it to mount the local file system. So these are all just Docker specific configuration elements. So if you're used to seeing Kubernetes containers or managing Kubernetes or Docker locally, this should look very familiar to you. And again, this is creating the representation of this logic is running on the edge. So I create this configuration, and then the other thing I create is what's called a routing table. And this is actually where you can send messages from one container into another. And I'm going to jump back to my slide to kind of show an example of that. So if you have, so these are our containers running on the edge, module 1 and module 2, and they have inputs and outputs. So the inputs are properties within my code that actually says, okay, I'm going to listen for data coming from the programmable logic controller that I'm going to get from over OPC, as an example. So those are inputs to this module. And this module is doing some localized processing of that and maybe sending it out to this other module that's actually looking at the data on the fly and saying, okay, this temperature reading is too high. I'm going to notify plant maintenance operator or supervisor to be able to make a change or adjustment. And then ultimately, at some point, I want to take that data and pass it up to the cloud. And that's what this $ upstream is. So you can kind of create this flow of how you want data to go from module to module and ultimately up to the cloud. So this is an example of what one of those might look like, where I'm saying that I want to take all the messages from module 1, so basically all of the outputs here, where the sensor type, so the output data, this example actually has a property called sensor type. So I'm saying if the sensor type is of type temp, then I want to send it to the input of module 2. So this module only knows how to deal with temperature sensors, as an example. So maybe I can take other output data types from this module and send it to a third module. So that's kind of how you can kind of string all of this together to be able to define what happens at the edge. So you can define the modules that are running on the edge, and I'm actually connected to this Raspberry Pi, and I can actually see that this is what IoT Edge does for me. These are containers that are actually running on my Raspberry Pi, so I can actually see that just like I told it to be configured, that it's taking port 3000 from my container and running it on, or opening it on port 3000 on the network interface within this particular Raspberry Pi. So this is how you can deploy custom code, but this also extends to, if I go to set modules, I can add a module that, when this loads, I can add, we have a number of marketplace modules or stream analytics. So stream analytics is a capability that runs native in the cloud that can look at this hot stream of data as it's arriving from devices and be able to make informed decisions or react very quickly. So you can take that configuration that you define in the cloud and actually push it all the way down to the edge. So IoT Hub has the ability to know, hey, these are stream analytics definitions that you've defined in the cloud, and actually allow you to easily package those and deploy those on the edge without having to actually build anything or author anything yourself. So when you think about that, this is this is a simple example of showing a single device, but where it gets really interesting is when it comes to managing these devices at scale. So I can actually create a deployment, and I'm going to go ahead and go to this one as an example. So I can say I want to change the process control parameters of one of those modules running on all of the edges that are in plant 1, and specifically the ones that are attached to line 1. So I can create these conditions where I can actually tell it to make these updates or changes in behavior to a subset of all the devices I have deployed. So this is in this case, I have another edge device is called IT Edge. So I created a condition saying where my device ID is IT Edge. But we talked about the device twin. I could create a property on my device twin that's called plant, and maybe what line, what station it's at, and be able to target those very specifically and highlight from the cloud what I want to deploy down to the edge, and the cloud will actually make all of that that determination. And when that device checks in, it'll say, hey, you're running on plant 1, line 1, station 1. You're supposed to have this new configuration that's been defined centrally at the IoT Hub. So it's a powerful capability to be able to take a lot of the computational power of the cloud down to the edge. So that's kind of my talk today for Edge. I don't know if you have any questions, Ron, or if this is enlightening. Certainly I have a lot of customers making use of this in various different ways to be able to make informed decisions about data that's being emitted from their piece of equipment. And it's also very quick to get stood up. It's not very expensive. Can integrate with plethora of different communication protocols and devices that exist on the market today. And you can take some of the other capabilities that natively run in the cloud, like machine learning, stream analytics, and be able to move them directly down next to the pieces of equipment that are generating that data.
Ryan, I think this was great. I mean, I learned a lot just listening to all this. So my takeaways are, first, this is not a solution that's just for the big 3 automakers of the world's largest manufacturers. One of the good things, and Ryan, maybe you can comment on this, is Microsoft has this cloud computing platform, all these IoT, IIoT capabilities, so anyone, even the smaller, tier 1, tier 2 automotive suppliers can all benefit from this, because you don't need, as in the past, you don't need to spend millions on your own servers. You can just set up your own application, code it, and be up and running, and you've got access to the same computing resources as GM, Ford, Fiat Chrysler, et cetera. I think that's one important takeaway. That,
yes.
That you shouldn't be overwhelmed, I think. And, a second takeaway is I talked to a number of people. The other good thing about Microsoft and what it does is if you do have a large developer team, you can create very customized apps. But at the same time, Microsoft has built into this a lot of pre-program applications. A lot of this can be set up through APIs, and you don't need to be a sophisticated Python hardcore developer. If you're just a general technologist, you can still architect many of these same solutions as well. Is that another relevant takeaway?
Yep, those are absolutely correct. So I talked a lot about being able to deploy something custom down to the edge, but we have a lot of built-in modules of services that are native in Azure, as well as modules that we make commercially available to be able to interface with things like OPC servers, which is a common way to get data from machines. And you can see just from a cost standpoint that 6 million messages, depending on what tier. There's some differences between these 2 tiers, but anywhere from $50 to $250 a month. So I could have lots of edge devices connected to this. We don't charge anything for the edge runtime. So this is pretty inexpensively, and with you don't need a whole lot of compute power if you're just gathering data. You can interface with pieces of equipment, start capturing some of that data. In my example of the building manufacturer, they had no idea what pieces of data were related to one another that could drive some quality disruptions in their product manufacturing. So, being able to take a lot of this data in and start building, machine learning models and try to identify where the correlations are across all of that data is really powerful. And to your point, you don't need to have, really, really big compute clusters to be able to do that. You can, turn that on when you need it in Azure and, dial it back down when you're done making that sort of analysis.
The other thing too is I know that Ryan was focusing on manufacturing applications, but also be aware the same type of industrial IoT can be used in non-industrial applications, be it distribution, retailing. I mean, any one of us can be creative and think, how can I capture data in my supply chain? Who knows? Let's see, a retailer, you might be able to track people walking through stores based on their smartphone that they might register for privacy regions in advance. I mean, there's just a wealth of solutions out there. And I think as all of us are now much more tuned to the power of technology and how we can use that for greater efficiencies, I think this is very insightful. I would encourage everyone, if you have follow-up questions, you can go to angelbeat.com, contact us. We'll be glad to put you in touch with Ryan and other subject matter experts. As I said, Ryan's based in the Michigan area, but he has colleagues around the country who can help you, whether or not in the East Coast, West Coast, or internationally, to help provide you with similar solutions.
Yep.
Ryan, is there anything else you want to add?
No, that's it. That's you made an important point on being able to use this across other industries. We have healthcare providers, fast food restaurants that all make use of this very platform I outlined. It's pretty general purpose and can be flexed in various different ways to do a lot of different things.
That's great. Well, thank you very much, Ryan. I really appreciate this. We appreciate everyone listening out there. I wish you all the best, and I'm going to end the webinar recording now.
All right.